Okay, let's dive right into this explainer. Today, we're unpacking what I'd honestly call a massive paradigm shift in artificial intelligence. For years, the whole industry has been completely obsessed with moving in just one direction, right? Bigger, heavier, highly resource-intensive black boxes. But what if the future of safety-critical AI isn't about just blindly scaling up parameters, but scaling precisely? Well, we're going to explore a native Rust cognitive engine called GoldWorm. It's a system that throws the billion-parameter playbook out the window, moving us toward a fully transparent, biologically faithful, zero-trust architecture. To really wrap our heads around the structural leap, here's how we'll break it down. First, beyond the black box. Second, biological fidelity in action. Third, dual-stream cognitive processing. Fourth, the zero-trust mandate. And finally, real-time interactive monitoring. All right, Section 1, Beyond the Black Box. This is all about the limits of scale and the incredible power of constraints. Think about the current industry standard for a second. We're talking massive, billion-parameter transformers. They're heavily reliant on opaque attention mechanisms, backpropagation, and totally hidden training loops. Honestly, they're power-hungry black boxes. GoldWorm completely flips that script. Instead of needing a massive cluster of GPUs just to guess at patterns, it uses a highly transparent, biologically grounded approach. It operates with just 302 neurons, running purely on Hebbian plasticity, all on a single core. That number is absolutely crucial, 302. GoldWorm routes language through a neural substrate of exactly 302 neurons. Now, why that specific number? It's because the architecture is entirely inspired by the mapped connectome of the C. elegans organism. If you know neuroscience, you know C. elegans is a tiny worm, but it's completely legendary because it's the only organism where we've mapped the entire nervous system. Every single neuron, every gap junction, every synapse is fully cataloged. It's just wild to think that GoldWorm uses this microscopic, transparent blueprint to actually power a cognitive AI engine. And because this engine is so incredibly lean, it's completely ditching billions of weights in favor of precise biological topology. It boasts staggering efficiency. We're talking about processing over 200,000 words per second. And it's pulling this off not on some million-dollar supercomputer cluster that's draining your budget, but on a single CPU core. It's really a masterclass in computational constraint that redefines operational costs entirely. Moving on to Section 2, Biological Fidelity in Action. Let's look at how inspectable synapses completely replace the black box magic matrices of standard AI. GoldWorm meticulously implements the exact C. elegans connectivity motifs. It's not just a generic neural net randomly guessing at connections. It's using actual biological topology. It uses band synapses to create neighborhood ring connections. It has specialized pharyngeal wiring where those first 20 neurons are densely coupled. You also have sparse feed-forward paths going from sensory to interneurons and command hubs that broadcast straight to the motor population. So every single structural blueprint is immutable and, best of all, completely inspectable. Now, the rule set for learning here is fascinating. Synaptic weights are strictly non-negative, and they are permanently clamped between 0 and 1. Crucially, no de novo synaptogenesis ever occurs. That means the system isn't just spontaneously inventing brand new mysterious synapses out of nowhere. It relies entirely on Hebbian plasticity, that classic biological principle where neurons that fire together wire together. Learning only strengthens or weakens the existing known synapses. That gives you a level of transparency and safety you literally just cannot get with standard deep learning. Let's jump into Section 3, Dual-Stream Cognitive Processing. This is where we see how GoldWorm solves a massive headache in AI, catastrophic forgetting, without touching backpropagation. So if you've spent any time working with neural networks, you know that if a model tries to learn from its own sparse outputs, it usually collapses into a self-reinforcing loop and just forgets everything it just learned. GoldWorm completely sidesteps this by using a dual-stream architecture. It physically separates the sparse action signal, which handles token selection, from the dense learning signal. So the dense pre-activation state acts as a sort of gradient substrate, keeping the actual learning alive, while that sparse stream just handles the output actions. The main engine driving this memory is called the echo reservoir. You can think of it as the system's hippocampus. It's basically a ring buffer that grabs hold of those recent dense states and couples them with a 302 by 302 Hebbian association matrix. When you query it, it nudges current activations toward patterns that were recently active together. It creates real, emergent associative memory purely through local, online Hebbian updates. No expensive external training loops needed at all. To actually manage the signal between these streams, GoldWorm ditches traditional softmax and instead uses Talus alpha Nmax activation. It's super clever because depending on the alpha value, the behavior dynamically shifts. It can go from a dense softmax to a sparse max, all the way down to a hypersparse winner-takes-all setup. There's a parameter in there called the Quillis bridge that smoothly anneals the state between these different levels. So based on the cognitive load, the engine can fluidly transition between broad creativity and strict determinism. All right, Section 4, the Zero Trust Mandate. Let's pivot slightly to operational reality and look at why this native Rust engineering is such a game changer for security. For any C-suite execs or systems engineers building mission-critical embedded AI, a Zero Trust Mandate is pretty much non-negotiable today. And the guarantees here are rock solid. First, it is entirely OOM safe, meaning out-of-memory safe, because all the matrices are pre-allocated with fixed bounds. Zero dynamic memory growth during inference. Second, it's completely panic-free. There are absolutely no risky unwrap commands lurking in the production code. And third, it's 100% deterministic. In environments where literally every single byte matters and unexpected failures are catastrophic, having a rigid structure like this isn't a limitation, it's an absolute superpower. And that mathematical rigor continues on a geometric level, too. Every single token is treated as a 128-dimensional coordinate, embedded on a nonlinear manifold. GoldWorm actually uses modified Gram-Schmidt orthogonization and Grassmannian fusion. Now, what does that deeply technical jargon mean in practice? It simply means the system preserves true multidimensional spatial variance at every single step. No arithmetic shortcuts, no scalar cloning, just absolute mathematical rigor from input straight through to output. Finally, let's step into Section 5, real-time interactive monitoring. This is where we get to literally watch this digital hippocampus form associations live. To really grasp the power of a fully inspectable system, you have to see the real-time proof of concept. GoldWorm comes with this incredible ANSI mission dashboard. Engineers can visually monitor the activation topography, which shows the 302-dimensional state as a live heat map. You can track Descartes drift to see exactly how rapidly the learning signals are changing, and you can watch the Hebbian strength histogram shift. You are literally observing the engine learn and adapt dynamically right before your eyes. Good luck trying to do that in a standard black box LLM. Here is how all that learning actually applies when you're using the conversational interface, the associative chat REPL. First, your input gets tokenized and routed through that 302 neuron connectome. Then, the dense signal gets captured in the echo reservoir. Next, the Hebbian matrix updates automatically, meaning it's learning your input instantly. And finally, the response decodes securely via energy minimization. It's learning from your inputs locally and securely, entirely bypassing any need to phone home to a server or rely on an external training loop. I absolutely love this quote from the project's documentation. GoldWorm, not a black box, not a billion parameters, just 302 neurons, doing what 302 neurons do. I think it perfectly anchors all of these intense technical specifications, the manifolds, the alpha Nmax, the dual streams, right back to the foundational philosophy of the project: simplicity, biological truth, and absolute transparency. As we wrap up this explainer, I want to leave you with a thought. In an era completely dominated by unsustainable complexity, power-hungry server farms, and opaque black box models, are you ready to embrace the transparent, zero-trust power of biological AI? Think about how this massive paradigm shift toward highly efficient, embedded cognitive engines is going to redefine the security and performance of your own deployments. Thanks so much for joining me on this deep dive into the GoldWorm paradigm.